All right. Well, thank you for giving me this opportunity to talk about my most recent New York State WRI grant, which did focus on trying to understand some of the impact our infrastructure may be having on surface water quality and water quality in our cities. So as mentioned, I'm Carrie Rodak. I'm out here at Union College in Schenectady, New York. Prior to this, I spent about 8 years at SUNY Polytechnic in Utica, New York. So you'll see some of the case study that I present was actually in Oneida County. So, and that was because I was there in Utica during the time. So when I picked a location, I picked Oneida County. So I want to start with a little background on what's going on today as we look at sanitation, our water infrastructure, and the environment. And in particular, I'm going to focus on sanitation as it relates to our wastewater infrastructure. So in 1947, I like to start with this quote. Mahatma Gandhi said that sanitation is more important than independence. So we've recognized the importance of sanitation to our everyday lives. This was not always recognized. But even in 1947, this was something that we were starting to understand the science and starting to understand the importance of sanitation. If you are aware, some of you may be, some of you may not be, but just a couple days ago, there was a Supreme Court ruling in the case of City and County of San Francisco, California versus the EPA. And this challenge to the EPA was related to end result requirements, which is really about how San Francisco phrased it, making them responsible for the quality of water in the body of water in which they discharge pollutants, which if you know the Clean Water Act, you might be like, well, of course. It's interesting, though, as we start to compare how we've implemented regulations and permitting in the past and how this deviated and kind of brought about this lawsuit. But the bigger question, or the thing that really struck me when I learned that this case was even in front of the Supreme Court and that they were ruling on it, was this question of how did we get here? How did we get to the point where a city and a county in San Francisco, California, right, is suing the EPA and saying, no, we'd rather put sewage in the water, right? So how did we even get to this point? And we got here for a couple different reasons. And a big one, and this applies to San Francisco, we have a lot of cities that have what are called combined sewer systems. And so if you're not familiar with how these work, back in the day, engineers thought they were being resourceful and saving money and saving time. And we said, okay, we're going to take the waste that's generated from homes and industry and commercial, so our municipal waste, and we're going to put it in the same pipe that we are collecting stormwater in. So we have two sets of pipes, they merge, they get combined, hence the combined sewer systems, and those two types of water will mix and flow together, and they will go to the wastewater treatment plant. So we might be over-treating this stormwater, but hey, it doesn't sound like a bad idea. We'll dig one trench, we'll put down one pipe, we'll make it a little bit bigger. Unfortunately, a lot of these systems are undersized for various reasons. Lack of knowledge of what the scale of the rainstorms we were going to see was when they were designed. There's climate change, there's population growth. So there's just a lot of factors. And really, in the end, these combined sewer systems are overflowing at an alarming rate and way more frequently than I'm sure anyone intended them to be overflowing. So that it really wasn't meant to be a common event. It's just become a little bit more common as we're starting to see these larger rainstorms. And these pipes and systems are undersized for what they are handling. So that's kind of one big driver in the US is this prevalence of combined systems, which we no longer put in place. But we have a lot of cities, particularly in the Northeast, that are older and that have these systems in place. There's also the piece of aging infrastructure. So we have sewage breaks, we have failing pipes, in the ASCE report card for New York State, they stated that 40% of sewers in the state are over 60 years old, and 10% of our sewer systems in New York State are over 100 years old. So they're over a century old. This is how old this infrastructure is. And so if you think about all the innovation that is going on in the world, we have sewer systems that are a century old. So we're really not seeing that same, it's not that we don't have research that's innovative. It's just the implementation of this is much harder when you start to look at the infrastructure, especially things that are buried underground. A third piece of the puzzle is absolutely money. Implementing changes and improving systems takes a lot of money. In 2022, that same report card from the American Society of Civil Engineers gave the wastewater infrastructure of New York State a D+ grade. So fantastic. D+ is, I guess, get degrees, but we'd like to see a better grade. And those grades are determined by practicing civil engineers in the state. And what they estimated in 2022 was that we need at least $38 billion to meet current deficits based on a 2012 Clean Water Needs Survey. So this is a large amount of money just to meet the deficits that we have in these systems that are old and some that are designed to intentionally release into our environment when they don't have the capacity. And then our fourth one, and this is my favorite, and what I think really plays into it, and you can tell I had fun with this slide, is a lack of knowledge. It's a lack of knowledge. It's a lack of wanting to know what happens when we flush the toilet, but a lot of people don't like to think about it. So they use the restroom and then magic, it becomes unicorns and rainbows, and they don't need to really think about what is happening to that waste, where it's going, and how it's getting there and how it's being treated. So these are kind of four things that I think have got us where we are in terms of our systems. And the question is, okay, how do we start to work at some of these issues? And so I'm going to kind of focus, I guess, mostly on this lack of knowledge, or how do we take what data we have and make something meaningful from it? And that's really the focus of this work. So the next section is kind of bringing us to reality in terms of the data that is available in New York State. And so this is the availability of information on sewage releases. So these are known releases of untreated or semi-treated wastewater into the environment. So straight from the New York State DEC website, there are many, many reasons we can have sewage releases. You can have weather, and that's certainly the case with combined sewers, where large rainfall will cause these sewers to overflow because they reach their capacity. You can have system blockages, insufficient capacity. You can just have structural, mechanical, or electrical failures. So pumps, for example, can fail, and those will can cause sewage releases. You can have broken pipes. You can have vandalism. So there's all sorts of reasons we can have sewage releases. Some that we can plan for and design for, and others that are simply just by chance, and we have to be prepared to kind of correct or fix those issues when they come in. This picture is a picture of a broken sewage pipe in Utica, New York. Back when I was out there, it was actually, I think, 2016, the first year I was out sampling the Mohawk River. I did not know kind of what the baseline conditions would be for our indicator bacteria that we use to try to identify potential sewage leaks. So I did not know that there was a sewage leak there, but in hindsight, my data clearly did show that. This was found by a kayaker who was just going down the Mohawk River and took a picture of it, reported it, and it was fixed within a couple days, but nobody knew it was happening. So there are a number of reasons that we have sewage releases, and some of the time it really needs to be observed to know that we have a release occurring. So in terms of data that's available, in that case with the kayaker, he happened to go by and see this broken pipe. Eventually, I think somebody would have realized what was going on. But when we know we have sewage releases, basically we have this law called the Sewage Pollution Right to Know Act. And this requires our publicly owned treatment works and publicly owned sewer systems to report sewage spills to the public within 4 hours of discovery. So once they know there is a spill, they have to report this spill. This law, or the data that they report, has shifted over the past few years. It's become a little bit more controlled and regulated in terms of what the expectations of this data are. Back when the act first went into effect, there was a lot of variability in the data that you get in terms of whether they have dates, times, locations. Now a typical response will have at a minimum the date and time of the spill, the location, the duration, the volume or a flow rate that will allow you to get to a volume, the treated state, is it fully untreated, is it semi-treated, why it's releasing, so is it a broken pump or is it rainfall in a combined system, and then any actions they're taking to correct this release. So this data is submitted now to the DEC, and they collect this information. And you might be thinking, well, that's great. We have all this information. We can use it. We can share it. I'm going to go to the website and I'm going to see, what does this look like? Well, it looks like this. You don't even have to go. It's a giant spreadsheet. There's actually 2 spreadsheets. There's an older one, which has even more chaotic data. And then this is just one screen of the data that is contained in this database. It continues for many, many columns, many, many rows. There's over 50,000 records in this database. And what you'll see is that some of the columns have blank places. Some are, you might see numbers that are, there's one in row 4, unknown gallons, in terms of the quantity or volume. So there is variability in terms of what is going on and what information is coming in, but this is actually a fairly good representation of some kind of homogenized data so that we can actually start to do something with this information. And I'll say people have tried, and I commend them after going through this journey myself. That this database is difficult to work with, and I'll get at some of that towards the end. So we have all this data. We need a plan. So you can't just release 50,000 lines of Excel to the community and say, okay, well, now you know what's going on. We need to have something that's a little bit more tangible to understand and evaluate all that data. So the next step, and this is really what the research was about, was to develop and apply some understandable but also relevant performance metrics to assess these sewage discharges that are reported in the Sewage Pollution Right to Know database. So if we look at this big database, what do we want to know? What would help municipalities? What would help the public in terms of understanding the scale at which we are seeing sewage releases within New York State? So there are basic statistics, and we certainly did some of those. The 4 main ones that I'm going to highlight, the first is kind of the simplest way to look at the data, and that is just the total number of sewage releases that are reported in this database. Some of the rows, you'll have one entry that says the spill started, and then the row after it might say the spill ended at this time. So it's not as simple as just counting the number of rows of data. Some of them are essentially duplicates or are related to the same spill. So we can go through and we can count how many spills occurred. The next 3 performance metrics are metrics that we use in system analysis. So if we are trying to determine how well a system is functioning, we can use these concepts of reliability, resilience, and vulnerability. So what we did is tweak these to apply them to sewage releases, basically. So the first one is reliability, and that really focuses on the frequency in which these releases are occurring. Technically, it's the probability of not having a sewage release on a given day, but it's really, again, looking at how frequently we have spills occurring in either a city, a county, a state, however you define it. Then we have resilience, which technically is looking at the probability that a spill is no longer occurring after some given time frame. For most of this work, we use 24 hours as kind of that deadline. A spill occurs, has it been corrected, or has our system gone back into a place where it has capacity within 24 hours? So it's really looking at how quickly does the system recover from a perturbation, from a spill, or from a large rain event that causes sewage releases. And then the last is vulnerability. And we defined this as the average volume of sewage released. So we look at all our sewage release reports, we calculate the volume, and we find the average volume of what was released. So in terms of the count, we want to see low numbers. In terms of vulnerability, we also want to see low numbers. For reliability and resilience, high numbers are good. So the more reliable, the more resilient, the better the system is performing. So we have our metrics, we have our database, and now we need to apply it. And this is where that WRI grant came in, was taking those performance metrics and actually applying it to a county. So like I mentioned at the beginning, I was out at SUNY Polytechnic in Utica, New York, which is in Oneida County. So I focused on Oneida County. I had also been sampling the water quality in the area for a long time. It was just time to look at these reports and try to understand how frequently combined sewer overflows were happening in the region. We knew they were happening, but we hadn't been able to really correlate water quality changes on the days that we were out there sampling with known sewage releases. So we wanted to go to the root of the data, which was this sewage pollution right to know database. So for those who aren't familiar, Utica, New York is a combined sewer system. There are quite a few CSO outfalls throughout the city. Those are shown in the map in kind of red circles. You'll also see some other circles with stars. Those are places where I had done water quality sampling before, so trying to get at the impact of these CSOs as the Mohawk River travels through Utica, New York. I'm going to look at the time period of 2017 to 2022. Anything before 2017, we see a lot of gaps in the data that makes an analysis of this type difficult. So we don't have volumes or we don't have durations. Around 2017, we started to see some consistency in the reporting that allowed us to start to really look at the data. So we're going to look at the count, the reliability, the resilience, and the vulnerability, along with just a few other metrics to get at really simple questions of like how many sewage releases occurred from 2017 to 2022, right? We can't just answer that, but with the database, if we analyze it, we can get to that information. So if we look at that entire 5-year time span, so 2017 to 2022, there were 273 releases in Oneida County, a lot of them in the city there where we have combined sewers. So this is not a surprise. We know our sewers are going to overflow. That's how they are designed to react when the system itself does not have the capacity to handle all of the water and flow that's coming into it. Of those 273, they occurred on 175 unique days. So that means that we would have more than one release on a given day. And that's also expected if you have a combined sewer system. So you have multiple outlets or outfalls that are reacting to, for example, precipitation events that are coming through the region. So we really only had 175 days within that 5-year period where we had sewage releases, but some of those days had multiple releases. The average duration of a release was 17.12 hours, so not quite a full day. That's also not too surprising if you think about the fact that these releases are being triggered by large rain events, because it is a combined sewer system. There are smaller ones that are breaks in pipes and things like that, but the majority of the releases in Oneida County are coming from that combined system and being triggered by rain. If we look at our 3 metrics, our system performance metrics of reliability, 24-hour resilience, and vulnerability, we see that 92% of the time we did not have a sewage release. So 8% of the days we had some sort of release occurring in Oneida County. The 24-hour resilience was almost 80%, which means almost 80% of the time the release had stopped within 24 hours. So either the rain that triggered it had passed, or the pump that had failed had been replaced. So some corrective action or just capacity of the system had kind of healed and gotten back to a point where it was no longer releasing sewage. The vulnerability, the magnitude of this is large. So the average sewage release was 3.15 million gallons. And that is also not super surprising for a system with a combined sewer outlet. If you get a really big rainstorm and it's long and intense, this thing is going to be releasing large volumes of water over a long period of time. But this is larger than what we're going to see in some of the data to come. So I want to look at resilience a little bit closer. So I've been defining resilience as a 24-hour resilience. So I said, okay, within 24 hours, almost 80% of our spills have stopped. We can actually define resilience at any time frame we want. So after we've pulled all this data in, we could, for example, look at an 8-hour resilience or a work day, basically. And almost half of the spills were corrected or had ended within 8 hours. So we can look at these different time frames. We could choose what we want that resilience metric to be. But for us, we just chose 24 hours out of convenience. But you could choose a different time frame. Right? But the 8-hour resilience being 50% is I think, pretty good that most of these spills had recovered within 8 hours, or the majority. We can also look a little closer at vulnerability. And when I did this in Oneida, I found this, what's called bimodal behavior, which I did not expect. And so this caused me to dive a little bit deeper into the data. And this is where kind of our first look at the quality of the data being a driver within the analysis. So anyone who's worked with models knows if you have bad data going in, you get bad predictions. They really aren't helpful if the data that goes in is garbage. Your model will spit out garbage. So what we found in Oneida County was that there were 2 reporting agencies, and one was the county, one was the city. And the city uses a constant flow rate in their estimate. So from 2017 to 2021, they estimated that flow rate at 10 gallons per minute. And then in July of 2021, they updated that estimate to almost 6,000 gallons per minute. So it's a very different flow rate. And so that peak that's on the left side of the screen is actually a bunch of releases associated with that lower flow rate, that 10 gallons per minute, and shifting to the 5985 gallons per minute started to create that second peak of data. So in reality, when they updated that gallons per minute, that was based on their observations over the years, and they decided, okay, this 10 gallons per minute is not the right rate for what we needed to use, and they updated it. And it's great that they updated it, but it also shows the kind of sensitivity of this method to the quality of data and the accuracy of the data that's going into this database. So that was where the WRI grant kind of ended. But since then, I've been working to expand this idea to all of New York State. So Oneida County was an initial test case to see if it even made sense to try and apply these metrics. When you think about the 50,000 releases and pieces of data in that database, obviously, it's helpful to start small and then go bigger to the state. So what I'm going to show is a small excerpt from the 2025 senior thesis of one of my students, Emmett Parkerson, who is getting his bachelor's in environmental science here at Union College. So Emmett took this idea and expanded it to New York State. So there were really 2 key pieces to his work. The first was to take these methods and these performance metrics and apply them throughout the state, because we have sewage release data for the entire state. And then he's also exploring correlations between demographics, income levels, anything that would fall within that perspective of environmental justice, to try and see where these wastewater releases are occurring and whether there is this imbalance in who is being impacted. So in terms of New York's infrastructure and the combined sewer systems that exist, approximately 50% of CSO releases are in New York City, or outfalls are in New York City. So that's going to be a hot spot we expect to see, because by design, there should be some releases of sewage there when weather comes through. Albany, Buffalo, and Syracuse are the next three big metropolitan areas with combined sewers. The Oneida County that I explored and I was looking at, where Utica is smaller than all of these. So it falls under the other communities category in this CSO distribution. So you may not see Utica and Oneida County pop up in some of this analysis, because the scale is actually smaller than a lot of these other CSO dense regions in New York. This is the plot of where those CSOs exist within New York. So you can see a lot of them down there in the New York City area. You can see a good number in the Albany area, Syracuse, and Buffalo. There's also quite a few over by Rochester. And Utica's not marked on this map, but it's just southeast of Rome there. There's a bunch of yellow dots on top of each other. That's where Oneida County is, where that Utica case study was. So the first thing that my student did is geocode and map all of the sewage releases that occurred within the database. So this was after a lot of cleaning of the data that he did, removing duplicates, things like that. But once he had refined that database, he said, okay, I want to plot them in GIS and just see where all of these releases occurred. And again, we're not just looking at combined sewer systems. These are any reported sewage release. There is one floating down in the water there at the bottom. We're trying to find that one and get it where it's supposed to be. But otherwise, you'll notice that the counties do extend into Lake Ontario there, where you see those dots. That's the actual boundary of New York State. But we can see kind of clumping of these sewage releases throughout the state. So he looked at a slightly longer time period than I did, because he started later. So he looked at, again, that 2017 is really the point where we can start looking statewide at the data that's coming in and have enough information to be able to do this analysis. And then he went into, I think it was June of 2024, so not all of 2024. And in that time frame, in the entire state of New York, we recorded 18,110 releases. And of those releases, it covered 2,131 days. So if you do the math there, the average number of releases per day would be 8.5 releases. And this makes sense, right? If you have a storm system coming across New York State, you would expect CSOs to be triggered potentially in multiple locations, and to see sewage releases occurring in multiple locations. The reliability was a whopping 4.7%, and I'll talk about that in a minute. The 24-hour resilience was 74.2%, and vulnerability, so the average volume of sewage that was released, was 1.5 million gallons. So the reliability of 4.7 is a little startling. And what that really was showing, or what that story is telling, is that there is not a boring day in New York. Approximately 5% of the time, we don't have sewage leaking somewhere in the state. So that is a kind of a startling metric when you look statewide, but it's a big state. There's a lot of cities, a lot going on. But that was certainly surprising to us once we worked the numbers, that there were very few days where no one was having a sewage release. I showed these numbers to my husband, who's a chemical engineer, and he does micro and nano scale things. And he immediately broke out his calculator, and he was like, I have to understand the volume of sewage that's being released. So he said, well, okay, if there's 18,110 releases over this 7-year time span, and the average release is 1.5 million gallons, then we have 27,650 million gallons, or 27.6 billion gallons of sewage, untreated or partially treated, being discharged in New York State. So to give you some idea of that number, because that number is just huge, right? According to the internet, that's approximately 83% of Saratoga Lake, which is about 33 billion gallons. It's about 27 Jacqueline Kennedy Onassis reservoirs in Central Park, which is about 1 billion gallons. Or for those who like rivers, it would take almost 2 days of the Hudson River outflow at New York City at its average flow rate to clear the amount of sewage that was released in those 7 years. So it is just this very large volume of water that we're talking about. So never a dull moment is kind of what we found if you're looking statewide. But statewide isn't as helpful as perhaps looking at a smaller scale like counties. And I'm going to go through this a little quick because I don't want to steal his thunder for anyone who is going to the Watershed Symposium at Union College in a couple weeks. He'll have a poster. But we looked at those 4 metrics across the state and we broke it down by county. So I'm highlighting the winner of each category when it comes to these metrics. So Erie County had the most sewage releases in that 7-year time frame with 6,859. They are a combined sewer system. That is not surprising. There's a lot of snow, there's a lot of precipitation, and maybe they're just doing a good job reporting when they are having releases. We can then look at reliability. So again, this is a higher reliability is better. So in our lowest bracket of reliability, from almost 50% to 67.5% of the time, we don't have releases. We have Erie County, Albany, Rensselaer, Ulster, and Orange. So some of those counties do have combined sewers. So they're going to have these not planned, but expected releases that occur. And then others, you know, as we look a little further in the data, there's some interesting things that come up in some of these other counties. We can look at our 24-hour resilience. So in terms of counties, our lowest bracket goes from 0% to 35.7%. So this means that approximately 36% of the sewage releases had not cleared up in 24 hours in these 6 counties of Tompkins, Cortland, Sullivan, Ulster, Dutchess, and Putnam. I'm also going to take this opportunity to highlight a data quality alert. So I already spoke about the change in how data was being reported by the City of Utica. So here, when we zoom in at Dutchess County and we look at the information that's being submitted, every release they reported was 24 hours long and had 144,000 gallons. This also extended into some of 2021 and into 2023, but all of 2020, we saw the same duration and same volume, which just realistically does not make sense for sewage releases. So what we're seeing here is this data is input by humans, and with it comes not just estimations of volumes based on their expert opinion, but we also see perhaps a lack of interest in providing very specific data. And again, because it's just going to this big database, there are incentives in both directions to over and under report your releases. And then our last metric we applied was vulnerability, again by county. And in our largest kind of category, we saw which goes from about 3 million gallons to 13.6 million gallons as the average volume of sewage released during that 7-year period. We see a number of counties: Monroe, Tioga, Broome, Albany, Ulster, Westchester, New York, and Richmond. So we do see a range of counties that are showing up in really all of these metrics. The only county that appeared in the low end of reliability, the low end of resilience, and the high end of vulnerability was Ulster County. And there's some interesting things going on with their data. I won't speak to it here, but it goes back to concerns about the quality, the accuracy of data in a database like this. So some conclusions. So many reasons we're where we are, and there are many, many different things that need to happen in order to advance our wastewater infrastructure. We are innovating. We have researchers coming up with great ways to remove PFAS, for example. But the implementation of innovation in wastewater and in our water infrastructure is difficult. It takes money, it takes dedication, and it takes knowledge. These metrics can be used to help communicate important parameters when it comes to system performance and how many sewage releases we're seeing. Are they long? Does it recover? We can answer those kinds of questions. But the data quality in this 50,000 data point set is highly variable, and in some cases, fairly suspect. So what we believe is ultimately happening, the idea behind this act was to provide the public with information. But what we're really seeing is a mandate to report, and there's very little buy-in to that data and what's being done with that data. So you have groups that are probably under-reporting spills and groups that are over-reporting spills. For example, that Dutchess County, they're probably not 24 hours, right? But because they put 24 hours in, they've now been highlighted in this talk because that's what their data says. So there are incentives to go over and under-report to avoid being fined, or to look better when these kinds of analyses happen. So we really need to find a way, if we're going to move forward and continue to collect this data, how can we ensure the data is accurate so that we can do analyses like this and come to strong conclusions and can use that information moving forward. So with that, I want to thank you, and I'll take time for questions. There's also a QR code if you are not aware of the Mohawk Watershed Symposium at Union College occurring in a couple weeks. This QR code should take you to the webpage. I should have double checked it. I did not, so hopefully that's where it takes you. I would just say we are close to capacity for the event. So if you are really interested in going, or you had planned to go and haven't registered yet, I do recommend that you do that. And again, my student Emmett Parkinson will be there with a poster that goes into more detail on that New York State application of these metrics. So thank you.